So you hit upload on a video, you see that little progress bar, and a few minutes later, it's live. Simple, right? Well, it turns out that behind that simplicity is one of the most incredible engineering puzzles on the planet. In this explainer, we're going to pull back the curtain and follow the journey of a single video through the heart of YouTube's massive machine. To really get a sense of the scale we're talking about, let's just start with a number: 500 hours. That's over 20 days of non-stop video. Now, that huge amount of content is the amount of video uploaded to YouTube every single minute. Let that sink in. By the time this explainer is over, years' worth of video will have been uploaded. The engineering required to handle that constant fire hose of data is just mind-boggling. So the real question is, how is that even possible? How does a system not just collapse under that kind of pressure, but actually deliver a pretty seamless experience for billions of users? Well, that's exactly what we're about to break down.
It all starts with the upload. This is the first massive hurdle. How do you get a potentially gigantic video file from your computer or your phone into YouTube's system and do it reliably and efficiently for everyone on Earth?
And I mean, these files can be huge. A professionally shot 10-minute 4K video can easily be 30 gigabytes. I mean, just think about trying to send a 30 gig file as an email attachment. It's just not going to happen. Now, the bad way to handle this would be to route that massive file through YouTube's main application servers. That would just clog up the whole system. So instead, they use a much smarter approach. Your computer uploads the file directly to their cloud storage. But how do they do that securely?
The key is this really clever piece of tech called a pre-signed URL. When you click Upload, YouTube's server doesn't actually handle your file. Nope. Instead, it generates this special temporary link. It's like a secret handshake, a one-time key that tells the giant storage system, hey, this user is legit. Let them upload their file directly to this specific spot. This is absolutely brilliant because it keeps the main servers free to do what they're supposed to do, run the actual website.
And it gets even smarter than that. Your browser doesn't try to send that 30 gigabyte file in one giant block. First, it chops it up into lots of little chunks, maybe 5 or 10 megabytes each. Then it starts uploading several of those chunks at the same time, in parallel. This is exactly why you can resume a failed upload. The system just looks at which chunks made it successfully and picks up right where it left off. It's an incredibly robust method used by pretty much every major service that has to deal with big files.
Okay, so your video is now safely inside YouTube's storage. But the work is really just getting started. Now it enters what's known as the video processing pipeline. This is where your one single file gets transformed so that it can be played by anyone, on any device, anywhere in the world. I mean, think about it. That beautiful, high-quality 4K file you uploaded is perfect for a big new TV, but it will absolutely never play on your friend's 5-year-old phone with a spotty connection. The file formats, the data rates, they're completely different. This is the core problem the pipeline exists to solve: universal compatibility.
To solve this, YouTube basically creates a whole family of files from your one upload. It transcodes it into a bunch of different resolutions, from that crystal clear 4K all the way down to a super small 240p version. It also encodes it using different codecs. You can think of these as different languages for compressing video. You've got older ones like H.264 for maximum compatibility, and newer ones like AV1 that give you the same quality using way less data. And finally, it packages all of these into different containers, like MP4 and web apps. So just how many new files are we talking about here? From your one original upload, the system generates somewhere between 15 and 20 different versions of your video. Each one is perfectly optimized for a specific device or network speed.
So, how do they possibly do all of that work without it taking days? They use a powerful model called a directed acyclic graph, or a DAG. Now, I know that sounds super complicated, but the idea behind it is actually really simple. You take one massive, complicated job and you break it down into hundreds of smaller, independent tasks that can all be run at the exact same time. So let's just visualize how this works. Imagine your video file just after it's been uploaded. It enters the pipeline as one single entity. The very first step is to split it apart into its most basic pieces. You've got the video stream, the audio streams, and all of the metadata. Now, each of these can be worked on separately.
And this is where the magic really happens. The video gets fanned out to hundreds, maybe thousands of different worker machines all at once. So while one machine is busy creating the 1080p version, another is working on the 720p version, and a whole other set of machines are just extracting thumbnails.
This massive parallelization is the power of the DAG. It turns a job that would take hours, if done one step at a time, into something that finishes in just a few minutes.
All right, on to the final piece of the puzzle, getting that video from YouTube servers to your screen. Your video has been uploaded and processed. Now, how does YouTube deliver that flawless, buttery smooth streaming experience to millions of people all watching at the same time?
You know this experience. You're watching a video on your phone, you walk into a room with weaker Wi-Fi, and maybe the video quality dips for a second, but it keeps playing. That transition is engineered to be so seamless you barely even notice it.
So how does your player do that? How does it magically know to switch from 1080p down to 480p at the exact right moment, all without that dreaded buffering wheel popping up and ruining the experience?
Well, the answer is a technology called adaptive bitrate streaming. And here's the most important thing to get. You're not actually downloading one continuous video file. Your player is downloading the video in tiny, few-second-long chunks. And before it requests the next chunk, it takes a quick look at your internet speed and asks for the highest quality version it knows it can download in time without making you wait.
So here's the play-by-play of what your player is doing. First, it downloads a small text file called a manifest. It's basically just a menu that lists all those 15 to 20 different versions of the video and where to find all their little chunks. Then, it is constantly monitoring your network speed, second by second. And based on that speed, it makes a smart decision, fetching the next chunk of the absolute best possible quality without ever causing you to buffer.
So as we wrap up, let's zoom out. We've gone through a lot of the nitty-gritty details, but it all really points to 3 foundational engineering principles that make YouTube, and really a huge chunk of the modern internet, actually work. Let's recap the big ideas. Number 1, direct uploads. This is all about keeping your main servers free and responsive by offloading the heavy lifting. 2, DAG workflows, which let you turn slow, sequential jobs into incredibly fast parallel ones. And finally, number 3, adaptive streaming, which is all about giving every single user the best possible experience their specific network can handle at that very moment.
These 3 concepts, they're the pillars of not just YouTube, but of so many services we use every single day. We're talking about file sharing sites like Dropbox, your cloud photo backups, even complex machine learning pipelines. So the next time you use one of these services and it just works, take a second and think about it. Now that you know these principles, where else do you see them at work?